Okay, so today what we're gonna do is talk about some Lewis dot diagrams, which is basically how we draw molecules. So we can start talking about molecular shape, molecular structure. So here we go. So hopefully you all remember how to find valence electrons. If not, quick review. Basically, if we've got our periodic table here, right, lovely looking periodic table. Anything here with like an A after it, right, 1A, 2A, 3A, those numbers, right, with an A after them, those are essentially going to tell you how many valence electrons there are in that particular column, right? So doing a simple dot diagram, basically what we're going to do is we're going to find and put dots for each of the valence electrons that's around an element. So like if we look at carbon, right, take carbon, we find it in column 4A, so we know it has 4 valence electrons, and we put 1, 2, 3, 4 dots. Really is that simple. If we take a look at phosphorus, right, phosphorus, we've got 1, 2, 3, 4, 5 valence electrons, so 5 dots. That is all there is to it. So that is a simple dot diagram. Now, before we get into drawing Lewis dot diagrams and the structures of these molecules, there are some terms we should know. So the first term, an octet. This is a group of 8 electrons around an atom, and electrons in both bonds and lone pairs count towards this number. Now, if you're saying, what's a lone pair? I don't know what that is. Hold on about 2 seconds, because the next definition, right here, lone pair. And a lone pair is a pair of unbonded valence electrons around an atom. So an atom may have more than one lone pair around it, which we will see when we draw some diagrams. The next term, bond, hopefully after the other videos you are familiar with the word bond, but it's a pair of valence electrons shared between 2 atoms. It usually contains 1 electron from each atom in the bond, and most atoms can form covalent bonds with more than 1 atom at a time. Multiple bonds. So this is not when one atom has bonds with multiple atoms. It is when there is more than one bond formed between the same 2 atoms. And so you can have either double bonds, so that's 2 bonds, or triple bonds, 3 bonds between the same 2 atoms. And we will see some of that as well. And then the last one here, electron domain. This is an idea that we will talk about a lot when we talk about molecular shape. An electron domain is any space around an atom that is occupied by electrons. A lone pair of electrons counts as 1 electron domain, right? Because they're a pair, they're together, they're taking up 1 area of space. And then any bond, double or triple, counts as 1 electron. All right, so any bond, single, double, or triple, counts as 1 electron domain because it is just 1 space that has electrons in it. And once we draw some diagrams, I will come back to that so we have a visual for that. Okay, the steps for drawing Lewis dot diagrams, and I will go through these in the examples as we do each step, but write down the element symbol, fill in the dots for the valence electrons, determine the central atom. This is either the least electronegative or the furthest from fluorine. If carbon is present, it's always going to be the center. Hydrogen and fluorine are never going to be the center. 3, you arrange the outer atoms around the central one. Throw 1 single bond between the center and each surrounding atom. drawn any valence electrons, not used in bonds as lone pairs. 4, you're going to check each atom for a full octet. Remember, that's 8 electrons, and we'll go through counting those up. And hydrogen can only have 2 electrons around it, so it does not need a full octet. And 5, if each atom does not have a full octet, you need to create multiple bonds to fill those octets. So I think examples is definitely the way to go for this, so let's get right into some examples. Step 1, if we are looking at, let's say here, oh no, I don't want to do that yet. Why are you not drawing? Okay, so let's say if we're looking at, I don't know why this is not working right now. I just want to draw. Let's go pen. Here we go. So if we're looking at this molecule, CH4. Okay, so we're going to start by writing down the element symbols and filling in the dots. All right, so C, we look, it has 4 valence electrons. It's in column 4A. 1, 2, 3, 4 dots. H, it is in column 1A. It has 1 valence electron. Great, first step, done. Now, we're going to determine the central atom, the least electronegative, or furthest from fluorine. So here's the deal, right? Hydrogen, further from fluorine. However, the 2 rules, if carbon's present, it's always going to be the center, and if hydrogen and fluorine will never be the center, right? So in this case, carbon, going to be the center, hydrogen, never the center. And I don't know why it keeps going back to this. So, pen. Okay, so then, right, carbon, hydrogen, 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 hydrogen. Or we got 4 of them. Okay, so now arrange the outer atoms around the central one, which I just did, and draw one single bond between the center and each surrounding atom, and draw on any valence electrons. So we've got 1 bond, 2 bond, 3 bond, 4 bond, right? And when we draw these bonds in, remember that these are bonds, they're created by valence electrons, and there is 1 electron being shared between each atom. So technically we've got an electron here, an electron here, 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 and here, right? So we've got our 4 valence electrons from carbon, right? All those valence electrons. We've got our 1 valence electron from each hydrogen. They're forming this bond. So all our valence electrons are used up, right? So the 4 from carbon, 1 each from each hydrogen, they're all used up, so we don't have to write in any lone pairs on this one. So the next one, all right, we're going to check if there is a full octet. So remembering that any bond contains 2 electrons, right? So when we've got a bond, we say there's 2 electrons. Here's another bond, 4, another bond, 6, and another bond, 8. Which, fantastic, right? We have a full octet. So everything is happy. So the last step, if each atom does not have a full octet, create multiple bonds. We don't need to do that because it's got a full octet. So here we go, another example. Let's do CO2, carbon dioxide. Great, so we're going to write down the elements. We've got carbon, we've got oxygen. If we look, carbon, 4 valence electrons. Oxygen, 6 valence electrons. Right, it's in column 6A. There's our carbon and oxygen. Determine the central atom. Least electronegative or furthest from fluorine. Great. Carbon is furthest from fluorine. Also, it's carbon, so it's going to be the center. So now we're going to arrange the atoms. So we have the center and our atoms to the outside. So we've got carbon, oxygen, oxygen, right? We're going to make one bond, and then we're going to fill in our other electrons. Remember that this bond has this one here, right, has one electron from carbon, one electron from oxygen, right? Same with the other one. So that's 2 electrons taken away from carbon. We've got 2 more. It's 1 electron taken away from this oxygen, so we've got 5 more. Same with this oxygen. Okay, great. Get rid of this arrow here. So now we have drawn our single bonds and we've put in valence electrons as lone pairs. Check each atom for a full octet. So if we count around carbon, we've got 2, 4, 6. Remember, because each of the bonds has 2 electrons, that is not a full octet. Okay. So then if we look around the oxygens, all right, both of these oxygens are the same. We have 2, 4, 6, 7. Also, not a full octet. All right, so we've got some work to do. Now, we need to create multiple bonds to fill octets. And we do this by taking electrons from each of the elements on the side of a bond, right, and putting another bond in here, right? We take those 2 electrons there that I just erased, and we put them in a bond. And we're going to do that for the other oxygen as well, because that one will also have 7 electrons still. Now it will look like this, and we count again. So if we count for carbon, we've got 2, 4, 6, 8. Great. If we count for oxygen, right, I'm counting for this one over here, we've got 2 right in the bond, 4 in this bond, 6, and 8. Which, great. The other one looks the same, so we know that everything has a full octet. We are done. Oh, and we're going to do one more. Last one for real. So we're going to write down the elements. For this one, let's do HCN, right? Hydrocyanic acid. So we're going to write down the elements. We've got 3 this time. H, it's in column 1A, 1 valence electron. Carbon, 4A, 4 valence electrons. Nitrogen, 5A, 5 valence electrons. Okay. Now, central atom, least electronegative or furthest from fluorine. All right, the furthest from fluorine technically is hydrogen, but it can't be the center. Carbon is further away from fluorine than nitrogen, so it's going to be the center, plus it's carbon. So now we're going to arrange our atoms. We've got carbon in the center, 4 valence, single bond, right? Our 2 leftover valence electrons, nitrogen, right? It had 5, now it's got 4, and hydrogen with its 1 valence electron, so it's got nothing else to put around there. Okay, great. Now we check full octet. Well, looking at carbon, hopefully right away you can see not a full octet, right? We've got 2, 4, 5, 6. For nitrogen, we've got 2, 4, 6. So neither nitrogen nor carbon has a full octet, right? Both of them actually need more electrons. Oops, I erased it too much. Right? So if we take one of the electrons from each of them, right? One from here, one from here, we're going to make a double bond, and we'll count again, right? Now, carbon, hopefully you can see it's got 7, right? Same with nitrogen, so still not enough. What we need to do, we need to make a triple bond. We're going to take one more electron from each of them, and we're going to draw in this triple bond. Hopefully now you can see, right, for carbon, 2, 4, 6, 8. Great. And nitrogen, same thing. 2, 4, 6, 8. Everything has a full octet. So that is the Lewis dot diagram for hydrocyanic acid. Okay. So now, before we're done, I have 2 more terms to remember. One is subvalent. And basically, all this means is that an atom can have less than a full octet when it is the center. And all elements in column 3A are considered subvalent, though the only one you're likely to see in this class when you're drawing a diagram is going to be boron. The other term is hypervalent. So this is an atom that can have more than a full octet when it is the center in a covalent molecule. And all elements in row 3 and beyond are considered hypervalent. So this means the only ones you'll see that are not hypervalent are boron, carbon, nitrogen, and oxygen. Okay, so we'll do one more, right? So if we look, we're going to take a look at phosphorus pentafluoride. So first thing, again, write down the elements. Phosphorus, column 5A, 5 valence electrons. Fluorine, column 7A, 7 valence electrons. Determine the central atom, right? Again, easy, because 1 furthest from fluorine. Fluorine's pretty close to fluorine, so it's not going to be fluorine. Also, fluorine's never the center, so the only one that can be the center here is phosphorus. Then we're going to arrange our outer atoms around the central one and draw one single bond for each of between the center and each of the atoms, right? So we've got phosphorus, 1, 2, 3, 4, 5 fluorines. We draw one single bond between each of them, and then put in any unused valence electrons as lone pairs. Phosphorus, all the electrons are used up. Fluorine, each one gets 6 dots, because there are 6 valence electrons that have not been used up. Okay, that step is done. Now we check each atom for a full octet. So we'll start with fluorines, right? So all the fluorines are the same. We've got 2, 4, 6, 8. Great, fluorine has a full octet. Now we check phosphorus. And we have 2, 4, 6, 8, 10. Okay, All right, so should not have 10. However, because phosphorus falls into that category, being in row 3 or beyond, right? It is hypervalent, it is the center, so therefore it is okay for it to have more than a full octet, right? Because it is the center and it is in row 3 or beyond. Right, so that is perfectly fine. That is what hypervalent will look like. Don't need multiple bonds. Okay, so before we leave, things to remember. Each line in a bond represents 2 electrons. Electron domain rules, right? So that's any single bond, double bond, or triple bond counts as 1 electron domain. Any lone pair of electrons counts as 1. You only draw Lewis dot diagrams for covalent compounds. And every atom must have a full octet, 8 electrons around it except for hydrogen, or if it's the center and it's sub or hypervalent. Right? So those are the rules, and I will see you in the next video.